All right, guys. So what we're going to be doing today is derivatives of inverse functions and also derivatives of inverse trig functions. Okay, and yeah, so these topics are not actually that hard, but initially they're a little confusing, particularly derivatives of inverses. People find that confusing at first, but if you pay attention, I think you're definitely going to get it. All right, so let's start with derivatives of inverses first. Derivatives of inverses. Inverse function. That's our first topic. Now, before we really do the derivative part of derivatives of inverses, I just want to talk a little bit about inverses. Okay, so let's see here. Suppose you have a function that has an inverse, like this one. Let's say, suppose y equals f of x has an inverse. I'm going to call it y equals f inverse of x, like this. Now, I just put y equals for both of them because we're just going to put these on the same graph here. Now, these are just kind of random functions that happen to have inverses, not any particular functions. But I'm going to put a couple points on here and put one there. I'm going to put one there. Put one there. All right. Now, what is this function? It looks like an exponential, but it probably isn't. Okay, now let me just label these points with points. So like 1, 1, 2, 3, 4. So this could be 1 comma 4. And this point here could be, nope, that's wrong. 0 comma 2 would be backwards. This one over here looks like negative 2 comma 1. Okay, and let's say that this is y equals f of x, right? Now, then you've got this function, y equals f inverse of x. And so the key thing to know about these two functions is that for the original function y equals f of x, you have the x and the y values 1, 4, 0, 2, negative 2, 1. That's for f of x. Then for the inverse function y equals f inverse of x, you have x and y values. They're going to be the same x and y values, they're just reversed. So instead of 1 comma 4, you're going to have 4 comma 1. Instead of 0 comma 2, you're going to have 2 comma 0. And instead of negative 2 comma 1, you're going to have 1 comma negative 2. And if you plot those all on your graph, you're going to see something interesting. So let's plot them. So 4 comma 1, where's that? 1, 2, 3, 4, 2 comma 0. That's there. 1 comma negative 2. That's there. Now that's only 3 points, but you could plot as many extra as you wanted. And if you did, you would see that the graph looks like this. Okay, got 4, 1, 2, 0, 1, negative 2. Okay, and then that's y equals f inverse of x, like that. Okay, now the reason that this is important for derivatives, which is what we're actually going to be working on in this section, is because, well, we switched the x and the y values, right? That's how inverses look. That's the key to this whole thing, right? So the key idea here, f and f inverse are the same functions really, but with the x and the y values reversed. Have all x and y values reversed. Now, why do we care about it? Well, the reason we care about it is because when we're doing derivatives, you can always think of your derivative as being a slope, right? So you have a slope of anything, it's like a change in y over a change in x, right? Or delta y over delta x, or rise over run. There's a lot of different ways you can write it, but it still amounts to y value on top, x values on the bottom, okay? And so if you reverse the x and the y values, then you're going to switch this fraction so that it's the other way around, okay? So that means if the slope of, let's say, f of x at a comma b is m. So the slope of f of x at a comma b m, then the slope of f prime of x, sorry, f inverse of x, the slope of f inverse of x at b comma a, right? It's got to be b comma a because you switch the x and the y values. So the corresponding point is b comma a. The slope of f inverse of x at b comma a is going to be what? Well, it should be related to the old slope, right? But the old slope at a comma b is m, or f. You go to the inverse, it's f inverse b comma a, and the slope is going to be 1 over m. Does that make sense? Because if you switch the x and the y values, then the rise over the run is going to be upside down as well. Right? Change in y over change in x is going to be the change in x over the change in y, or the inverse. So just to make it concrete here, like if I come over here and I just pick a point and we find the slope, and I don't know what that slope is, but let's say that slope is like m equals 3 over 4 or something like that. Okay, that would mean if you come to the corresponding point on the other graph, like this one, have this slope, that m would be 4 over 3. That in a weird place. Oops. Mistakes were made. Okay. So there, that slope would be 4 over 3. So what I'm saying there is just whatever this number is, this is the reciprocal on the f inverse, because they're kind of mirror images of each other. Not kind of, they are mirror images of each other. They're mirror images across this line. Y equals x. Right? And so this right here is the key to the whole thing. That means that the slope of f inverse at a comma b is m, then the slope of f inverse of x at b comma a is 1 over m. Right? Now, so intuitively, all of the questions in the homework work out like this. Now, I'm going to give you a formula. I'm going to derive the formula, and then we're going to use the formula. So this right here doesn't have any, well, we're not using the formula yet. So this is just from the idea that I just gave you. Okay? So, wait, why am I doing that? I don't want that. So here's an example. Like, let's suppose, let's see. Let f of x equal, let's just say 5x cubed minus 10x. Yeah, that's fine. Okay. Now what I want is find f inverse prime, that's the derivative of the inverse function, at a certain point. Now I can pick any point that I want here, but I need to be able to figure out what it is. So I'm going to use, let's see. So if I put a 1 in right here, what am I going to get? If I put a 1 in, I'm going to get -5, right? So that's the number I want there. Okay. So find f inverse prime of -5. Okay, that's the derivative of the inverse, right? Derivative inverse. So that's the derivative of the inverse evaluated at -5. Okay, and then they'll usually be nice enough to tell you something like this. Note f of 1 equals -5. That's key information there. Okay. Now, here's how you could do it. So you know that the 1 and the -5 go together. You know x equals 1, y equals -5. That's for the function f, right? This data right here corresponds to the function f. All right? So what you're going to do is they want the inverse evaluated at -5, but that's not what I'm going to calculate. What I'm going to calculate is I'm going to calculate the derivative of f. I'll find f prime, not f inverse prime, f prime, and not at -5, but at 1. Okay? I'll find f prime at -1. And so let's do it. Let's find f prime at -1. That should be easy, right? Let's do it. So f of x is 5x cubed minus 10x. That means f prime is, well, just take the derivative using the power rule. You bring the 3 down in front, you get 15x squared. Derivative of -10x is -10. I want to evaluate it at -1. So put in, I said -1, but 1. Put in a 1, you get 15, 1 squared minus 10. So what do we get there? 15 minus 10. 15 minus 10 is 5. All right? Now, let's just take stock of what we just did here, okay? What we just did was this. So at the beginning, they told us this. F of 1 is -5. That's telling me that 1 comma -5 is on the graph of f. So 1 comma -5. 1, 2, 3, 4, 5. So down here. Okay? That's 1, -5. And what's the slope there? The slope there is 5. Okay? So I don't know what the function looks like here. But what I do know is right here, the slope is 5. Right? I don't know what the entire rest of the graph looks like, and I'm not gonna graph it. All I know is that at 1, -5, the slope is +5. Well, what does that mean in terms of the actual f inverse function that we're being asked for? So all of what we did here, this tells me that so if slope of f at 1, -5 is 5, the slope of f inverse at -5, 1 is, what is it? 1 over 5, right? That's the relationship that we got here from picture and from what we wrote right here. Because you switch the x and the y values, which makes the slope go upside down. So what that tells you is for f inverse on the same picture here, if you went to negative 5, 1, 1, 2, 3, 4, 5, 1, 5, 1, the slope should be 1/5, so it should be like this. Now again, I don't know what the entire rest of the graph looks like. All I know is that if this one's 5, this one's 1/5. Okay? So what does that mean? Well, here's a summary. Oops. Here's a summary. We know that f prime at 1 is 5. That tells me that f inverse prime at negative 5 is 1/5. And the reason these two go together is because they told us that, oh, that's not what I wanted. They told us that f of 1 was negative 5. Okay, and that's why the 1 is the y value there, or the x value there, and the y value is the value that goes into the f inverse. Okay, so that's a little bit of kind of just understanding the situation, right? That there's 2 points that you're talking about, one on f and one on f prime, and the slopes are reciprocals of each other, like 5 and 1/5. Okay, now what's the formula? Well, I'm going to derive it. So derivation of formula for derivative of an inverse. So a lot of you guys like formulas better than, just understanding stuff. So we'll do it. Derivation. So let's start out with this. What are we starting out with? Let's say we have y equals f inverse of x, okay? And we want the derivative. We want f inverse prime, okay? Now here's the problem. I can't take the derivative of both sides to get the derivative of f inverse because I don't know what that is, right? I'm trying to figure that out. So what you do is for your first step, you take f of both sides. Say take f, I mean apply the function f to both sides. So f of y equals f of f inverse of x. Okay. So far so good. Now what happens here? What happens here? You have f of f inverse of x. Those cancel, right? Because they're inverses, property of inverse functions say that those cancel each other out. So you have f of y equals x. Okay. Is this what I want? I don't know. I hope this works out. We're 20 minutes in. I don't want to have to redo this. Okay, so we have f of y equals x. Now let's take the derivative with respect to x. By ddx. So ddx f of y equals ddx x. All right, let's actually take those derivatives. So on the right, that's easy. It's ddx of x, so that's just 1. On the right-hand side, you're going to have to do the, what's it called? The rule. What's it called? Chain rule. That's what it's called. So it's ddx of f of y. So that means for the chain rule, it's f prime of y times the derivative of what's inside, which is dy dx, or you can just call it y prime. I'll call it y prime. Like that. And then notice that the original thing we were looking for was f inverse prime. And f inverse was y. So if we can find y prime, we'll have what we want. So solve for y prime. This is a lot like logarithmic differentiation. So y prime equals 1 over f prime of y. Okay? So far, so good. We solve for y prime. Now, that's almost what we want, but I don't want to call this y right here. Don't want to call this y. I want to replace y with what y is equal to using y as f inverse of x. So replace the y, and we get y prime is 1 over f inverse, f prime of f inverse of x. Right? And that is basically your formula. 1 over f prime of f inverse of x. That's the derivative of the inverse function. I'm going to write it out a little bit nicer. So the formula in its final form is going to be this. This is the one you're going to need to do the homework, basically. F inverse derivative evaluated at a. Now, if you look at what we just did here, this was not evaluated at a, it was evaluated at x. But in all of the problems that you're going to be working on, they're going to assume that you have a number to plug in. So I'm just putting an a in there. You can put an x in there if you want. What is it? It's just what we just did. It's 1 over f prime of f inverse of, and if you plug in an a, it's an a. Right? And that's your derivative of an inverse formula. Okay, I'm going to try to make this prettier here. First of all, get rid of that. Second of all, take that and move it. Oh, terrible things. Again. Someday I'm going to know how to do this. Okay. I'm just going to keep it that shape as a mark of my shame. All right, and that is the derivative of f inverse of x evaluated at x equals a. That's the formula that you need. So how would you use it? Well, before you use it, actually, just remember this, right? Like, important to know. If you're going to use that formula, it's important to know. Let's say I give you this. If I tell you, if you know, like f of, I'm putting in numbers here, f of 3 is 7, right? That means that 3 is f inverse of 7. Okay? And if that's tricky for you, like this is what you should know, you shouldn't have to do any work there. But if you don't, then there's kind of a middle line of work that you can do where the middle line of work is if you had f of 3 equals 7, and then you did f inverse on both sides, then what happens is on the left, the f and the f inverse cancel and leave you with 3. On the right, nothing cancels and you just get f inverse of 7, right? But the point is, you should be able to start with this and get to this almost immediately, okay? Otherwise, the problems are going to be confusing. All right, with that in mind, how could we use it? Well, like this, right? Example. Let's say let f of x, let's just say let f of x equal sine x. Okay. We want find f inverse here. F inverse prime evaluated at 1/2. Okay. Now, technically, we're being asked there for the derivative of an inverse function, but we're nowhere near being able to talk about the derivative of inverse sine yet. So this is not how you're going to do this later on, but I just thought I would do this weird example here. Okay, and what they're going to tell us is a nice fact. What is f of pi over 6? 1/2, right? So this is the type of information that they give you right here. That's the type of information they give you. Function, what they want, and an extra point on the curve. Okay, so what does the solution look like? So the solution for this looks like as follows. If you want to use the formula, it looks like this. First of all, we're going to need f prime at some point. Okay, what is f prime? Well, if f of x is sine x, f prime is cosine x, right? Now those derivatives typically are going to be easy in this homework assignment. Not always, but I mean most of them. So f prime is cosine. Okay, now we want to use our formula. So what we're asked for is f inverse prime of 1/2. And according to the formula, it is, look at it right here, 1 over f prime of f inverse of whatever the number is. So just write it out. 1 over, well, I'll write it this way. 1 over f prime of f inverse of whatever the number is. Okay, so there you go. Now from here, you just need to work it out from the inside out, right? The first thing you need to do is figure out this. I don't know why I'm numbering here. Figure out f inverse of 1/2. Now, you should not have to think very hard, right? The reason you should not have to think very hard is this was given to you, right? F of pi over 6 equals 1/2. So the only two numbers are 1/2 and pi over 6. So you definitely should be able to figure out which one's which there. So what is f inverse of 1/2? It is pi over 6, right? Remember, this is just the same as what I just highlighted up here. If f of pi over 6 is 1/2, then pi over 6 is f inverse 1/2. Okay, so you figure out that. The next thing you need to do is actually just evaluate f prime of pi over 6. And that's why I already calculated f prime, because I knew I was going to need it. So this is 1 over f prime, which is cosine pi over 6. So 1 over the cosine of pi over 6. What's the cosine of pi over 6? Square root 3 over 2. So this is 2 over square root 3. Or if you rationalize your denominator, 2 squared 3 over 3. And we're done. Okay, now this problem right here is pretty much that entire section. Okay, it's all just find the derivative, evaluate it at the point. I'm going to just very briefly look at the homework and see if I see anything interesting. Already confused? Okay, there we go. Homework's written out of order and couldn't find the assignment. Blah, blah. Okay, yeah, let's just do this one. So the next one is just, this is straight off the homework. For me, it was the first question. For you, maybe not. Q of x. 2x cubed plus x squared plus 3x minus 15. They tell me we want find Q inverse writing hard again, find Q inverse prime of minus 9. And then they tell me, note, wow, in the world, Q of 1 equals minus 9. All right, so before we really get started, make sure you understand that. Q of 1 equals minus 9. That tells me that 1 is Q inverse of minus 9. I'm definitely going to need to know that, right? So there you go. What else do we need to do before we get started? We're going to need to find Q prime. So I'm not even using the formula yet. Let's just find Q prime, because I know I'm going to need that derivative. So what's Q prime? Well, it's just the derivative of a polynomial, easy peasy. So we got 2x cubed. So the derivative is 6x squared. Derivative of x squared is 2x. Derivative of 3x is 3. Derivative of negative 15 is 0. There's my derivative. All right, now let's use the formula. Use doesn't start with a y. Use the formula. So we want Q inverse prime of minus 9. By the definition, it's 1 over Q prime Q inverse negative 9. And then you just work this from the inside out. So evaluate that. What is Q inverse of negative 9? Well, we already did that, right? Q inverse of negative 9 is 1. So it's just Q prime of 1. Now, how are you going to evaluate Q prime of 1? Well, you got Q prime right there. All you got to do is plug in 1. Just plug in a 1. So you're going to get 6, 1 squared plus 2 times 1 plus 3. So 1 over, what is that? 6 and 2 and 3. Is that 11? That's 11. So 1 over 11. Type it in. Like magic. Okay. There's another one exactly the same, but it involves the quotient rule. Yeah, let's do that, because I think that's probably about as hard as it gets. All right. So find, oh, it's a G this time, not a Q. G inverse prime of minus 2 given G negative 3x plus 2 over x minus 8. Supposed to be an 8. Did not happen. Did not happen. Okay. And we are given, note, G of minus 14 equals minus 2. Now, as always, they're giving you that number, which matches that number. But then also, that that's the number that goes with it, right? So the negative 14 and the negative 2 are the numbers that you're going to need in order to do this. All right, so what's the work look like? Well, we know we're going to need G prime. So find G prime. So G prime is going to need the quotient rule, right? Because we have a quotient right there. So we're going to do the quotient rule, which you can write a few different ways. The bottom function times the derivative of the top function minus top function times the derivative of the bottom function all over bottom function squared. Now those derivatives are actually pretty easy though. So, right, what's this derivative? That derivative's just going to be minus 3, isn't it? And then you've got this derivative. That derivative, the derivative of x minus 8, is just going to be 1. Okay? So what do we got to do? Let's just work out this fraction here. So I've got x minus 8 times negative 3. That's going to be minus 3x plus 24. And here, the 1, that's easy. So I just need to distribute that minus sign. So minus 3x is plus 3x. And then minus 2 is minus 2. 2, I swear. All right, combine like terms here. Actually, in a little bit weird way, we got minus 3x plus 3x. Those go away. So I just have 24 minus 2, which is 22 over x minus 8 squared. All right, we've got the derivative. We're going to need that at some point. Okay, so now let's go to the formula. So what am I asked for? G inverse prime of something. Negative 2. So that's 1 over G prime, G inverse negative 2. Again, you always work these from the inside out. So we need to know what is G inverse of negative 2. The number, right? What number? Well, it's right here, right? Here's where it is. The negative 2 and the negative 14 go together. So the inverse of negative 2 must be negative 14. So you have G prime of negative 14. So you've got to evaluate that now. And that's what this is for. So plug in negative 14 and we're going to get 1 over 22 over negative 14 minus 8 squared, which is going to be weird. Oh, no, it's not. So that's 1 over 22 over, and then that's looks like negative 22 squared. Interesting. Or 22 squared over 22, which is 22. All right. So 22. That's my answer. All right. So that is derivatives of inverses. Just going to click through a couple. Back. Yeah, all right. One more and then we'll stop for good. We'll just move on to the next topic. Okay, last one. Last one here. Let t of x equal 5 minus x. Find t inverse prime 2. Note t of 1 equals 2. Right, so notice how they always give you the same information. It's always going to happen. All right, I know I'm going to need the derivative of t, so let's find it now. T prime is, you got to remember how to do the derivative of square root function. So remember this formula. d dx square root x is 1 over 2 square root x. Okay, you could use the power rule, but this formula is going to make it easier. So the derivative is, because we're doing the derivative of this, 1 over 2 square root 5 minus x times the derivative of what's inside for the chain rule. What's the derivative of 5 minus x? Minus 1. So my derivative is minus 1 over 2 square root 5 minus x. All right, so we found the derivative. Now we can move on and actually use our formula. Use formula. So what are we looking for? We're looking for t inverse prime of 2, which is 1 over t prime, but I wrote negative t prime of t inverse of 2. Work it out from the inside out. So what's t inverse of 2? Roll up. I believe it is right here, right? T of 1 is 2. So inverse works backwards. So t inverse of 2 is 1. So now you got to put a 1 into your function there. It's actually easier just to do this kind of off to the side, right? I've got the derivative up here, right? So what is t inverse of 1? It's negative 1 over 2 square root 5 minus 1. So it's negative 1 over 2 square root 4. So it's negative 1 over 2 times 2, which is 4. So come back over here, 1 over negative 1/4, which is negative 4. All right, and that's it. That's how you use the formula for the derivative of an inverse. Not so bad. How are we doing? We are 43 minutes in. So I'm going to stop this and then just start a different video for the inverse trig. Am I? No, I lied. Keep going. All right. Derivatives of inverse trig. All right. Now, I'm not going to go through and do a lot of effort to define the inverse trig functions. I'm going to give you the idea, and you're going to have to do some reading if you want to get a better idea, right? Trigonometry is a prerequisite for this class. But so where does inverse trig come from? Question mark. All right. So, example. Let's start with y equals sine x. Now you know what that looks like. I'm going to do a terrible job drawing it right now, but I mean, you know what a sine function looks like. So, like that. Yeah, exactly like that. Now, this does not have an inverse. It doesn't have an inverse because in order to have an inverse, it needs to pass what we call the horizontal line test. That means that it can only, a horizontal line can only intersect it in one place. If you put a horizontal line through here, it hits here and here and here and here and here and here, right? Infinite number of places. So it doesn't have an inverse technically. So to get an inverse, you need to restrict the domain. So you restrict the domain to a 1-to-1 section. I wrote 1-1, but that's the usual abbreviation for 1-to-1. To restrict the domain to a 1-to-1 section. So a little piece of that graph will pass the horizontal line test from here to here, right? Just this much from here to here. That much passes the horizontal line test, right? You can cross that with a horizontal line, it only hits in one place. Okay, now what is that 1-to-1 section? For the sine function, it's negative pi over 2, positive pi over 2, and the negative 1, 1. That's the piece of the graph that we're looking at. Now then, where does the inverse come from? Remember from the previous, I was going to say previous lecture, but no, from earlier 50 minutes ago, what is the relationship between f and f prime? You just switch the x and the y values, right? So switch x and y to get inverse. Get the inverse, which is going to be sine inverse. What's it look like? Well, switch the x and the y values. So instead of being x goes from negative 1 to 1, or sorry, instead of being y goes from negative 1 to 1, it's going to be x. So we're going to go negative 1 to 1. And then previously we had negative pi over 2 to pi over 2 on the x-axis. Now that's going to be on the y-axis. Looks like that. Okay, and so that is what the graph of y equals sine inverse x looks like. And so you can read the book if you want graphs of all the others, because there's 5 more, right? But this is the graph of y equals sine inverse of x. Okay, now how do we find derivatives? Okay, of course there are 5 more. There are 5 more. We have this one, we wrote it. Then there's a cosine inverse. There's a tangent inverse. There's a secant inverse. And there's a cosecant inverse. And then there's a cotangent inverse. Put those all in parentheses if you want. Okay, so there are 6 total, right? Also, there's alternate way to refer to them, which I'm not going to do, but you need to understand it. For all of them, instead of calling them inverse secant, like I wrote this one, you could call them arc secant. Like that's the same function. And that's true for any of them. I'm not going to write it for all of them, but like this, you can say arc sine and so on. Okay, so they all could be referred to in 2 different ways. So we have 6 inverse trig functions. They all have restricted domains. They're not all negative pi to pi or negative 1 to 1 for the inverse function, but they all have a limited domain. So how do we find derivatives though? So the way you're going to find derivatives is, well, you're just going to use the rule that we just came up with on the derivatives of an inverse function, pretty much. So the find or derive actually derivative of inverse trig function. So derive, we're going to do the math to come up with it. Now there's 6 of them. We're not going to do 6. We're only going to do 1, but all of the steps are the same. All right. So let's do the sine as our example. Sine's not the easiest. It's just one of them. All right. So find d dx sine inverse x. Okay. Now we could pretend that we don't know what the derivative of an inverse function is. Maybe should, but I'm not. I'm going to use the formula that we had up here. Well, you know what it is, the derivative of an inverse, right? I'll use d dx of f inverse, awkward notation. What was it? It was 1 over f prime of f inverse of x, right? So in this case, if we're trying to find this derivative, the f is regular sine, right? The f inverse is, of course, sine inverse. Okay. What's f prime? Because we're going to need f prime. So f prime is going to be the derivative of a sine x, which is cosine x. So we have f, f inverse, and f prime. We need all those. So according to my formula, d dx of sine inverse x is going to be 1 over f prime of f inverse of x, which is 1 over f prime of, all right, what's f inverse of x? F inverse of x is sine inverse of x. Okay. No problem. Then we're going to need that. Then we're going to need to know what is f prime. Well, f prime is going to be cosine. So 1 over cosine of sine inverse of x. And that's your derivative. Except that it isn't. Okay, so that's the derivative, but it's not really the derivative because, well, actually it is the derivative. It's just not the way we want it. I don't know why I said it wasn't the derivative. It is. It's the derivative. But we don't like to write it that way. Okay, so what we like to do is we like to simplify this. Simplify. Okay, now there's a specific way to do this, and it's a little bit tricky for people to understand. So we're going to see it a few times in this class, by the way. So try to understand it now. If you don't, you're going to see it later. So here is how it goes. So suppose, or just not suppose, we have, what do we have? So up here, I have f inverse of x equals sine inverse of x. I want to call that something. So what do I want to call it? I think I want to call it sine inverse of x equals y, or theta. Call it theta. Theta equals sine inverse of x. So let's just say I have this. Okay. Now I know that I just added this theta here. Bear with me. Okay. So theta is sine inverse of x. That means sine theta equals x. Why is that? That's that inverse of an inverse thing, right? So if that does not make sense to you, I'll do it in 2 steps. So if you apply a sine to the left-hand side, you apply a sine to the right-hand side. On the right-hand side, Just going to cancel. You're going to end up with sine theta equals x. Okay, so far so good. You might be wondering what we're doing, why we care, but I'm going somewhere here, really. So theta equals sine inverse of x, sine theta equals x. Now, think about trigonometry. When you're doing trigonometry, the trig functions have something to do with a triangle. So if I draw the triangle here, like this, and I put a theta in here, and I want to label the sides of the triangle with values, okay? And I've got a sine right here. What sides of the triangle give you the sine function? Hopefully you remember it's the opposite side over the hypotenuse, okay? So sine theta is opposite over hypotenuse, which is also x, and I'm going to write x over 1. Now, once you do that, you've got x equals opposite over hypotenuse, and that tells you that the opposite side of your triangle should be x, and the hypotenuse of your triangle should be 1. So you label your triangle that way. The opposite side should be x. There it is. The hypotenuse should be 1. There it is. The third side of your triangle you get from the Pythagorean theorem. Just going to write a squared plus b squared equals c squared, which for us is like a squared plus 1 squared equals a squared plus x squared equals squared. So a squared is 1 minus x squared. So a is square root 1 minus x squared. Now I know I did that fast, but you're not going to be using this today. So you do all that work, you label this triangle. Why did we do all the work to label the triangle? The reason we did all of the work to label the triangle is because now we're actually going to be able to use that to simplify this answer over here. And so here is how it's going to look. We're just going to refer to our triangle and the other work that we have here. So 1 over cosine sine inverse x, right? That's what I have. That is 1 over cosine of, well, what is sine inverse x? Sine inverse x is theta. So theta. Well, now you have 1 over cosine theta. But what is cosine theta? What is this? Why? There. What is cosine theta? Well, cosine theta is going to be from your triangle. You have to remember what sides of the triangle it is. So what sides of the triangle is the cosine theta? Cosine is adjacent for hypotenuse. So the adjacent side is here, and the hypotenuse is here. So this is 1 over adjacent, which is root 1 minus x squared, over the hypotenuse, which is 1. So you get that. Right? Now that's a lot of work. That's a lot of work. But we were eventually able to get from here to here. Right? And that's what we were trying to do. So our final formula is this. So d dx sine inverse x 1 over square root 1 minus x squared. And you're only able to plug values in here between -1 and 1. I'm not going to bother saying that because it's obvious. Okay, that's your formula. Okay, so that's a lot of work. But what I want you to remember when you're looking at this and freaking out, thinking that you don't understand it, is you're not going to be doing this. Okay, this is just where the formulas come from. What you're going to be doing is using the formulas. So the formulas are as follows. Okay, formulas for inverse trig derivatives. dx sine inverse x. That's the one we just did. And okay. And you could write this if you want. Not allowed to plug in 1. Because you'll have a divide by 0, but don't really need to write it, but there it is. What about the derivative of cosine? Now, as you can probably guess, the work for cosine is going to be just about identical for the work for sine. But there's one extra minus sign that pops up. Again, x is not allowed to be plus or minus 1. All right. Tangent. 1 over 1 plus x squared. Cotangent. Inverse. Negative 1 over 1 plus x squared. Secant inverse. 1 over absolute value x square root x squared minus 1, and x is not allowed to be 1 or 0 because you'll get a divide by 0. And last one, cosecant x negative 1 absolute value x square root x squared minus 1. Same rules. Okay, now again, you do not have to derive these, but you have to use these. Okay, now you can clearly see that they're in pairs, right? Like you've got sine and cosine inverse right there. Same formula, only difference is a minus sign. Then you've got tangent and cotangent. Same formula, the only difference is a minus sign. And then you've got secant and cosecant, inverse. Same formula. You can go over it twice. Only difference is a minus sign. Okay? We're not going to go over derivations of all of those, but the steps are the same. It only differs when you go to, simplify it. But you use the triangle the same way I used a triangle. Now, great. What does the homework actually do? Like, what are you expected to do with these formulas? Well, basically, all you're expected to do with the formulas is just add that to the list of functions that you know the derivatives of. And they're not easy, they're not hard, they're just really normal. So like, examples. Example 1. Find r prime x if r is x to the 7th arc sine x. So notice that they're already using arc sine, so you just have to remember the alternate notation. All right, so how do we do it? So we want r prime, but we've got this and we've got this, right? That's two functions multiplied together. So you just have to do the product rule, right? Product rule. So the product rule is going to be like x to the 7th prime arc sine x plus x to the 7th arc sine x prime. Right? No different than lots of other derivatives that you use the product rule on. So then you go to take your derivatives. R prime is x to the 7th prime. So the derivative power rule is 7x to the 6th. Arc sine x, you're just copying that because we're not taking the derivative, plus x to the 7th. And now we have the derivative of arc sine. Well, you're just looking it up. Roll up. What's the derivative of arc sine? 1 over square root 1 minus x squared. So 1 over square root 1 minus x squared. That's it. You're just copying it. You're just copying it in. That one is that one. So 7x to the 6th. You can write it that way, or sine x plus, and all you can do here is just put them in one fraction. And that's about all you can do. Stop it. Right? And that's really pretty much like 100% of this homework assignment. You just have to combine things with different kinds of, what's it called? Chain rule, product rule, quotient rule, that kind of thing. Here's another one. Find p prime of x. P equals arc secant to the 10th. So this is just going to be chain rule. So you've got to remember the derivative of secant inverse, which, I mean, obviously you're not at the moment, but get used to it. It was this. Okay. Let's scroll up, make sure. There it is. That's the derivative. And all we're going to be doing is we're finding the derivative of arc secant x to the 10th, right? So that just means in your formula for that x and for that x, you're going to be replacing them with x to the 10. So p prime is going to be 1 over absolute value x to the 10, right? Because you have to replace the whole thing with x to the 10. Then square root x squared, that's x to the 10 parentheses squared, minus 1. Then I did not leave enough room, but there's going to be a chain rule, right? So they're going to have funded. There's going to have to be a chain rule where you multiply by the derivative of what's inside. So what's the derivative of x to the 10th? 10x to the 9th, right? So if you want to simplify this, p prime of x is, on top you have 10x to the 9th. On the bottom, we've got square root x to the 10 to the 2 is x to the 20 minus 1. You've got x to the 10 in an absolute value. But remember that anything to an even power is already positive, so you don't need the absolute value. So it's actually like this. And then from there, you can cancel out 9 of those with 9 of those, just leaving you with x to the 1. And so it should be 10 over x, square root x to the 20 minus 1 should be p prime. Right? And the thing there is that knowing the new formula here, knowing that new formula was what was new in this section. Nothing else was, right? Oh, also, I guess for the record, I just typed this in to the computer just to see what it would say, and this one was the form that they had in the computer. So they did not cancel anything. So maybe that was the computer answer. So maybe don't simplify too much. You get it wrong. Just looking for a different type of question here. Do one more and call it a day. Man, these really just are the same question over and over. Over and over. Over. Okay, there's a new one. Last one. Find h prime of x if h of x is arc cos x to the fifth. Right. So what makes this one different than kind of what we just did was where the power is, right? Like in this one, the 10 is inside the arc secant, whereas on this one, the entire arc cos there, oops, oh battery, oh no. The entire arc cos is inside that fifth power, okay? So when you're taking the derivative, you have to evaluate from the outside in. So the first function you're going to evaluate the derivative of is the fifth power function. And the second one you're going to evaluate the derivative of is the arc cos. So this is the first one you're going to deal with, and this is the second one you're going to deal with. So what's the derivative? H prime. So start with the power function. The derivative of the derivative of something to the fifth power is 5 something to the fourth. So 5 arc cos x to the fourth times the derivative of what's inside. So what's the derivative of arc cos x? Well, scroll up. There it is. -1 over square root 1 minus x squared. So -1 over square root 1 minus x squared. So what's your final answer for the derivative? Putting a prime. It is, you can write it this way, 5 arc cos x to the 4 over square root 1 minus x squared, and I lost a minus, so I'll put it there. And I'm done. Okay, so those are the derivatives that you've got. And I think I need to be done before my battery dies, and also this is 1 hour and 13 minutes, probably longer than you wanted to sit and listen. So that's it for right now.